Let's take a look at directed reading A for global winds and local winds. This is Chapter 1, Section 3. Remember as you're going through to make any corrections that you need to make on your own worksheet. Also feel free to write down in the margins any notes, anything that I explained differently than the book. Alright, so number one, what causes differences in air pressure? And that's the unequal heating of the earth. So different surfaces on the earth heat up differently. The ocean heats up differently than the sand, or than dirt, or than grass, or mountains heat up differently. So all these different surfaces heat up differently, and that causes differences in heating and then differences in air pressure. 2. The movement of air caused by differences in air pressure is called wind. And that's pretty much one of our learning targets right there. Movement of air caused by differences in air pressure is wind. 3. Air is warmer and less dense than surrounding air at the equator because the equator receives more solar energy. That's why the equator is warmer. It gets more direct solar energy. 4. Because air at the poles is colder and denser than surrounding air, it sinks. So that denser air drops down towards the equator. 5. High pressure areas are created around the poles as cold air sinks. So around the poles there's high pressure air. 6. After high pressure areas are created around the poles, cold polar air flows toward the equator. That's A. One thing I'll point out right now, that air always moves from an area of high pressure to an area of low pressure. So at the poles there's high pressure air, and that air is going to move towards the equator where there's low pressure air. 7. Large circular patterns of air movement are convection cells. 8 is pressure belts. And 9 is Coriolis effect. So because the Earth is spinning, our atmosphere spins as well. And that spinning effect, we call it the Coriolis effect. All right, you'll be responsible to know all these different global wind patterns. So 10 is C. 11 is D, that's the doldrums. That's more of like a lack of wind than a wind pattern. 12 is A, polar easterlies. 13 is B, westerlies. And 14 is E, horse latitudes. So the horse latitudes and the doldrums are areas where there's really very little wind. And then these other three, A, B, and C, are areas of pretty strong wind. And then our final global wind pattern is the jet stream. So that's way up high in the stratosphere or upper troposphere. And we didn't even know about it until we started flying jets up there. But it goes all the way across the globe. 16 is A, mountain breezes. That's a local wind. If you live by mountains, then you might have a mountain breeze. And 17, explain how geographic features can cause local winds. So local geographic features such as mountains or lakes or buildings or roads can produce temperature differences that cause local winds. So like you hear about the lake effect in Chicago, and there's wind created by the Lake Michigan, and that's a local wind because out here in Carroll Stream we don't really feel that wind, but in Chicago they feel that lake effect wind. Okay, so make sure you do any corrections that you need to on 1 through 17 and be ready to turn that in.